industry resource persons also. So I welcome you, madam, and
Thank you very much, sir.
I will take the privilege to introduce you as a part of our program. So it is our privilege to introduce Dr. Shalini Dolai, a highly accomplished professional in metallurgical engineering and material science, specializing in corrosion engineering and high performance coatings. Dr. Dolai earned her PhD from IIT Bombay, where she developed expertise in cutting edge electrochemical techniques and functional coating formulations. Dr. Dolai's career highlights include currently serving as a senior manager in R&D team at Everest Industries, where she leads advanced research in material development. Formerly working as a team leader at Saint Gobain Research India, where she spearheaded ISO 9001 certification, material innovation, and electrochemical competency establishment. Mastery in nano pigment synthesis, corrosion testing, and the development of functional coatings. With her technical brilliance and extensive experience, Dr. Dolai has made significant footprints in advancing the science, materials, and coatings. We are honored to have her here to share her expertise and innovative approaches. So I welcome once again, madam, and I request you to start your session.
Thank you very much for this opportunity, sir. And I will share some of my personal cases which we have solved in the industries as an example of how we tackled the corrosion related problems and what are the modern technologies. So I will share my screen.
Yeah, you share, madam. I will stop my sharing. You can share now.
Can you see my presentation?
Yes, madam. Yes.
Yes. So today's topic is on new technologies in preventing metallic corrosion.
Madam, just I interrupt. Just make it PPT view.
Yes, I did. It is in PPT view only.
Full screen is not there.
Okay,
Yeah,
let
this
me.
corner icon. Yeah, that one.
Yeah, can you see now full screen?
No, madam. Or else you have to share entire screen.
Okay, okay, I will do that. Just a second. Is it okay now?
Yes, yes. It's okay now. You can continue, madam.
Okay.
Thank you.
So I don't know how many of you are aware of material science and the corrosion stream. It is not a very common subject, but there is a huge demand for this role in India. And we have been looking for material scientists, electrochemists, and corrosion engineers in our field, but it is extremely difficult. So, in future, if you want to do your masters and PhD, this could be one of a potential subject. Why? Because today I'm going to present how we solve some of the industrial problems with this knowledge. Before going into the case studies, I would like to give a small introduction, like what is corrosion and why it is important to understand it. Corrosion, in simple terms, it is a reaction of any metal with oxygen, carbon dioxide, humidity, or any pollutant in the atmosphere, and this metal gets converted into oxide and that metal oxide will have all detrimental properties which can lead to lot of accidents. That is called as corrosion in general terms. But what in terms of thermodynamics, what happens is, I will take an example of iron. Iron is usually present in nature as a magnetite or iron oxide, but
Yes, yes.
yeah. So, uh, so I will tell you an example. So, what happens to iron? We usually extract it from iron ore, which is an oxide, either ferrite or magnetite. Then we apply lot of energy to convert it into pure iron. Now this pure iron has acquired energy in melting all this process, and now it becomes unstable and it is looking a chance to go back to its original form, which is iron oxide. So whenever there is humidity, chloride, or any pollution in the atmosphere, it reacts like this. Iron reacts with oxygen and humidity and it becomes iron oxide. That is this is the natural behavior which is shown by almost all the metals. So when iron corrodes, it will show red rust. When zinc corrodes, it will show white rust. When copper corrodes, it will show blue color. Can anybody guess why copper rusting shows green color or blue color?
Copper carbonate.
Yes. So what happens is copper reacts with carbon dioxide in the atmosphere, or it will react with SO3 in the atmosphere and forms copper sulfate. Both of them have green or blue color. That is why we see this bluish color. So this is the basic corrosion mechanism. And why we should study this topic? Because the global loss due to corrosion is 205 trillion rupees, which is 4 to 5% of GDP, which is huge. With the knowledge of corrosion, this can be prevented, and it also has lot of environmental impact. You all love Eiffel Tower, right? And it looks beautiful, but if you go nearby it and see it, this is how it looks, because it is made of wrought iron and it is highly vulnerable to corrosion. And Paris spends almost 130 crore rupees per year to repaint it. Almost 60 tons of paints get consumed every once in 7 years. The kind of VOCs that is getting generated due to this paint, there is a huge environmental effect. And there are accidents and loss of life. One of the example is Bhopal gas tragedy, where the metal pipes were corroded due to this MIC gas. There was no monitoring, due to which the leakage happened and many people lost lives. This could have been prevented. And these, you may think that these are very old cases, Bhopal gas tragedy, but recently in Gujarat, in 2022, 141 people lost life because there was an accident in the Morbi bridge where the bridge got corroded. It was supposed to be replaced with new material. Instead of that, it was just painted, due to which many people lost life. So even today, these kind of accidents happen, and that is why the knowledge is very important. But why are we facing these issues? Don't we have this knowledge? The answer is no. We had this knowledge. One of the example is Delhi Iron Pillar. Just imagine 1600 years ago, this was built, and till now it doesn't corrode. And the similar examples we can see, like brass, for example, which is used in making temple bells. It was invented in 5th century. Till now, if you visit Konark temple, you can see metal clamps which are not rusted. And in medieval era, our kings were using weapons which was made of wood, steel. All these are example of knowledge of metallurgy and prevention of corrosion. and how we can use this knowledge in the modern era. We are going to understand. Before that, we should also understand causes of corrosion, because many times just by understanding the cause, we can prevent or we can find a solution to avoid it. The first cause is the environment. Humidity, temperature, pollution, and seawater are the most detrimental factors. So, among all the countries in the world, the most humid or tropical countries like Brazil, India are more vulnerable for corrosion. This is where we get lot of disputes in industries. Many times we tend to follow European norms or ASTM, American standards, but sometimes we need better than that, because those countries don't face corrosion. And when we use same standards in India, we will face lot of problems. So we have to develop our own standard, and this is a very important map which is available in this website developed by CECRI, SICRI, Karaikudi Institute, located in Tamil Nadu. So what they found is the corrosion is not uniformly happening in India. The coastal regions, which are more hot and humid, and also have chloride ions in the atmosphere, shows highest corrosion. So when you do material selection, you should keep in mind that for coastal regions, you need special materials. The other reasons which can cause corrosion are chemicals, basically exposure to acid or bases, then oxidizing agents, and microbiological corrosion is also very common. This usually happens in the body implants, like our stents and other materials, dental implants, etc. But in India, we also have a special case which I solved during my PhD. That is, in India on railway tracks, it is a common practice to discharge urine, and that causes corrosion of the railway tracks. And other reasons could be physical properties like mechanical stress, surface roughness. The more is the roughness, the high probability to catch the dust, and the surface energy is high, so more vulnerability for corrosion. Then poor surface preparation and design flaws. And another important reason is choosing of materials. Here you can see that when a copper wire is fixed with iron pipe, what happens is the electrons from iron pipe starts traveling to copper pipe. This is like basic thermodynamic. Like if you put a cold body and hot body together, what will happen? The heat will transfer from the hot body to the cold body. Similarly, when you put metals with different electrode potentials together, the electrons will travel from one metal to the other, and one of them will corrode faster. In this case, the iron pipe got corroded. So it is always better to put similar metals together. It's always preferable to avoid dissimilar metals. Similarly, while choosing weld material also, we have to keep an eye on the electrode potential of what weld material we are going to use. So these are some of the causes. Now, this is not very important, but I would like to give a glance on it, because there are types of corrosion. Uniform corrosion means, let's say you have a metal like this, and the thickness that is getting removed due to corrosion is uniform. That is called as uniform corrosion, and this usually happens in rust and other things which we see at home. And in localized corrosion, this is very dangerous, because this could be very microscopic in nature. We may miss it. The way the pipe got corroded in Bhopal gas tragedy, it may not be visible if you are not checking properly, and it can lead to catastrophic failure, which can be fatal. So those kind of corrosion could be due to dissimilar metals, which leads to galvanic corrosion. And then if there are impurities in a water flow, those can cause erosion. And if there are some nut and bolt system which are moving left and right, it can cause fretting corrosion. And if you put a metal with a non-metal, the area of contact, it gets corroded, which is called as crevice corrosion. Similarly, there are many types of corrosion, and identifying the type of corrosion can help us to choose a solution for it. Now, how to measure it? There are many methods, direct methods and indirect method. Indirect methods, you can go for physical techniques like visual inspection or measurement of loss of thickness or weight loss, etc. But these are not very efficient. If there are localized defects, you need some advanced technologies. There are many technologies, but out of which what we use in industry are these, mainly electrochemical testing, like linear polarization resistance, electrochemical impedance, and we don't have to go into detail, but the basic principle is electrode potential. So what happens? I mean, how will you check a structural integrity of a bridge or a building? Inside the concrete, you have iron bars. You cannot see it outside. How do you know whether the iron bar is healthy or not? Do you have any idea, like how can you check the quality of that iron bar? Any guesses? I think I got some answer in the message. Okay. So what we do is we put one electrode inside the concrete, and that electrode touches the iron rebar, then it measures the electrode potential. The positive the electrode potential, the better it is. If the electrode potential is negative, then it is prone to corrosion and it is time to change it. This is how the structural integrity of buildings or bridges is monitored. Now, natural corrosion is one side, but when we develop a new material, we cannot wait 1 to 2 years for it to corrode. We want to develop our materials within 3 to 6 months. In that case, what we do is we develop accelerated corrosion test methods, where, sorry, we use a chamber like this, and there will be a cycle of humidity. Then one very concentrated salt solution keeps falling on the metal coupons which you keep here. We usually accelerate the process so that we can understand if I have three materials, like material A, B, and C, which one has maximum resistance to corrosion. That I can study using this machine, which is called as the neutral salt spray. I can put those materials inside it and I can check the weight loss. And the other method is electrochemical test method, where till now we were talking about electrode potential, right? So the oxidation happens when the metal gets distracted from its natural electrode potential and shifts towards negative side. So here we will apply voltage and forcefully try to shift it to negative electrode potential, where the material starts corroding, and then we can measure the corrosion rate. These are the common methods which are used in industry for a new method development. Now, uh, this is the setup used for electrochemical technique. This is called as a potentiostat, and you can place your working material here. This tank is filled with NaCl, sodium chloride, which is highly corrosive, and using a computer, you can record all the data. You can calculate the corrosion rate using this formula, and when you have three different metals, let's say I have gold, I have copper, I have iron, the corrosion rate of iron will be more compared to copper compared to gold. I can get that sequence within half an hour using this system. So one of the case study I will explain, where galvanic, the topic name is galvanic protection. We feel that in order to avoid corrosion, we have to apply a coating, right? The answer is right, but there are other methods. For example, you can see these patches. This is a ship hull, which is made of stainless steel. And next time when you go to some port, you can observe it. There are some zinc blocks kept here. So what happens is these zinc blocks supplies electrons to your ship hull. And whenever a metal becomes electron rich, it becomes corrosion resistant. That is the basic mechanism. And that mechanism is called as galvanic protection. You can see these kind of applications in automobiles, furniture, etc. You might have seen partition boards like this, gypsum partition boards, and then ceiling. Usually you don't see any metals outside, but inside if you see, there will be skeleton structure like this. Usually this is a galvanized steel. So our company gave me a case study that in many places in India, after some days, some red color bleeding is happening. Why it is happening and how to stop it? Then the moment I heard it, I knew that it is happening due to corrosion of iron. And what we were using pure zinc, 99% zinc on iron. And once the zinc layer, I mean, zinc keeps donating its electrons to my iron to protect it. While donating these electrons, the zinc gets consumed and it completely goes away from the system. Once the entire zinc is consumed, iron starts corroding and that red color bleeding happens. So using only zinc is not useful. So what happened? Here is the mechanism that you can understand. I have one iron. Now in my atmosphere, there are corrosive elements, oxygen, water. It sits on the surface of the iron. Wherever it sits, from that part, electron starts transferring to the other part. This part is called as cathode. And since the electron is removed, here the metal gets oxidized and it forms iron. Now what we were doing, we were applying a pure zinc coating. Zinc is giving electrons to my iron, it is protecting, but in this process it is getting converted into white rust, and this white rust is very chalky and powdery. It is getting removed from the system. Once all the zinc is consumed, my iron is corroding. So what we did, we went for another coating, which is aluminum 55% and zinc 45% coating, where zinc and aluminum both supply electrons to iron, but aluminum forms aluminum oxide in this process. Unlike zinc oxide, aluminum oxide is stable and forms a passive layer, so it delays my corrosion. But due to these kind of big chunks of aluminum oxide layer, the coating was brittle. So whenever there are some mechanical impact, the coating was breaking and again the corrosion was happening. Now the third approach was to go for zinc aluminum magnesium coating, which is flexible like zinc coating but has double electron protection from zinc, aluminum and magnesium. And the magnesium ions can migrate in my system, and wherever there is a cutting, it can travel to that part and it can offer corrosion protection, which is called as healing. I hope I am not boring you. In case you have any doubts, you can ask me in between.
No problem, ma'am. No.
Yeah.
It's going on good.
Okay. So you can see we used the same techniques which I explained earlier. In a neutral salt spray, we kept all these three coatings. The zinc coating was corroding at a very high speed, whereas jam coating didn't show any signs of bleeding or red rust. But this test took 45 days for me to conclude, and the results were not very conclusive. Visually, we can tell this is better than this, but how to quantify it? Is it 5 times better, 10 times better? We cannot quantify it. So we went ahead with the electrochemical test where we can calculate the corrosion rate directly, and here I can clearly tell it is much better. I can quantify the corrosion rate here. So this was one case study, and I explained all of this, so I'm skipping it. And another case was shower cubicle. In shower cubicle, we have hinges like this. They are usually coated with nickel and chrome, and the base is made of brass. Here we have brass, we have nickel, and then we have this top layer is this 8 micron layer is nickel, this is copper, and very thin, we cannot see it in microscope, but there is a chromium layer. Now this was showing pitting corrosion. You can see in your washrooms as well, if you have these kind of hinges, small black dots will be there. Now how to prevent it? Should I change my brass substrate itself, or should I increase copper thickness? Should I increase nickel thickness, or should I do something with the chromium? The game is to improve the life of the product with least expenses. So again, we studied the corrosion rate of each layer. We tried to understand which one will act as cathode, which one will act as anode. You can see this kind of corrosion was happening. So what happens is, in this case, it is reverse. Brass is an anode, and nickel and chromium acts as barrier. The electrons from brass was getting transferred to nickel, and these kind of these kind of pits were getting formed. So whenever there is a bleach or air quality is bad, this kind of corrosion was happening. So again, we did electrochemical test, and we identified the three possibilities. We found that changing the brass grade can impact the mechanical strength. If I use some other grade, the mechanical strength will reduce, and for higher copper grade, new tools are required, which is huge investment of cost. So this was not an option. And the top coating, which is chromium, if I change it, my aesthetics will change, and our architects are very particular about the aesthetics. So this is also not an option. So we found that maybe increasing nickel layer can be beneficial from aesthetic point of view as well as the cost, and the mechanical properties will remain same. So we studied it. We took bare brass. By keeping all other coating thickness same, we just varied nickel alloy thickness, and we found reduction in the corrosion rate dramatically, uh, almost by 1,000 times, and the pitting corrosion reduced significantly. So this was one of the approach. Now, any doubts or discussions so far?
Madam, we will take at last
Sure.
question answer session.
Okay. So other advanced technologies, this is a coating which we developed during our PhD. So what is happening here? What is happening here? We try to develop a biomimic of a lotus leaf. When you observe water droplets on a lotus leaf, it doesn't remain, it flows. So if you look the lotus leaf in a microstructure, you can identify two things. There are some nano-sized bumps, and the overall surface tension of the lotus leaf is very, very low due to a wax kind of coating. So using nanotechnology, we developed a similar kind of coating in lab where the surface became hydrophobic. So if the substrate is not coming in contact with water, dust or anything, it becomes corrosion resistant. So how we were measuring whether the substrate is hydrophobic or not? Um, so we were using an optical camera, and this is a water droplet. If the surface tension is very high, it spreads on the surface. And as the surface tension reduces, it starts forming like a bead. So in this particular coating, we achieved 155 degrees of contact angle, which is a very good hydrophobic surface. How we achieved it? So we took one siloxane coating. Siloxane coatings are known for their low surface tension, and then we added nano particles of SiO2, iron oxide. We explored different types of iron oxide shapes, spherical, cylindrical, then zinc oxide also we explored. Among all, SiO2 was giving the highest hydrophobicity, and that's how we achieved this coating. And this coating is being used on car windshield in high-end cars, where whenever there is fog in the atmosphere or rain, the glass will be clear. And another coating is a self-healing coating. This coating is still under development. It is not in the market right now. The concept is that inside my coating there will be micro capsules which are filled with polymeric coating, and whenever there is a scratch, this polymer coating starts leaking, and that will start filling up my scratch. It cures when it is exposed to sunlight, and here you can see that one of the glass itself healed itself, and this is a metal where a small film is formed, and this is how the corrosion resistance can be prevented. This is a metal, in this scratch is the vulnerable area for corrosion, and now since it is healed, the corrosion is prevented. There are many other approaches as well, but the main challenge to mass produce this product is making these capsules is very expensive. The procedure is very difficult, encapsulating the polymer inside, and then even after so much effort, what happens is it works only once. Once the polymer is leaked and it forms a film, it is consumed. If there is another scar, there is no healing effect. So now there are research happening for better mechanisms to achieve this property, like geopolymers, etc., which cross-link themselves. And then this is another case which we used in Saint Gobain. So what was happening? We wanted to use artificial intelligence to predict the corrosion. So earlier I showed you neutral salt spray test, which takes 45 days, and then even electrochemical test has limitation. If you have big parts, you cannot measure it. electrochemical measurements are limited to very small size of samples. So to overcome these challenges, we thought, can we predict corrosion? So whatever studies we were doing in lab, we were feeding it to a machine learning software offered by Comsol. There is a company called as Comsol, where we can put all the data or learnings, all the experiments which we are doing in lab can be fed into it and it learns. And then here is one case study what we did. So we had this nut and bolt system, and let's say I am using one steel substrate and I am putting zinc screw, or vice versa. If I am choosing some dissimilar materials, if I'm changing the material, what will happen? If I'm using a magnesium alloy washer, then what will happen? Without doing any experiment, can we simulate that data? So using a CAD, we developed this model, and then we gave all the details, what material is used, what its electrode potential, etc., etc. And then it predicted the corrosion rate. It shows that this yellow is the most vulnerable part where the corrosion can start, and you can see the similar results in the real life. The washer got corroded because among all the materials which we use, magnesium is having the most negative electrode potential, and it was vulnerable to corrosion. So without doing any experiment, this was able to predict. So this, what happens is, when we use these kind of systems, our time for experimentation gets saved. We get the output very quickly. So that is the role of AI moving forward. Let's say, what is the catalyst that is accelerating the corrosion rate, or how to develop 3D models, which part of your entire product could be the most vulnerable area for corrosion, and accuracy, reliability. And in many cases, the corrosion tests are being done using acids, and it could be risky to humans. In such cases, AI can be used. So this is the role of artificial intelligence in coming future. So I finished my lecture earlier, and we can have an open discussion now about the topics.
Okay, madam. Thank you. So participants, the session is open for the discussion. Anybody can ask the question, unmute and ask.
Hello, madam.
Hello.
Yeah. Good evening, madam.
Good evening.
The session was excellent, madam. But one thing I need to ask you, madam. The one slide you have shown me, that electrochemical test method.
Yeah.
Right.
Yes.
So there 1 meter is there, and some 3 materials we are using, and through the computer we are measuring by using computer. So basically, which software using to test that things, madam?
Okay. So there are many companies which are offering this software, but we were using Biologic software.
Okay.
The machine which we were using was from Biologic. Software is also Biologic, EC Lab.
Okay, okay.
Software name is EC Lab.
Okay. That means what? Whichever the software we are using, it is depends on the tools which we are using.
Yeah, it depends on what potential. There is Gamri. Gamri instrument, they offer their own software.
Okay.
Okay. Similarly, Biologic is there. Biologic offers ESAB software. So why I chose this software? Because it depends on what is your budget.
Okay, okay. Yes,
Biologic software is very expensive. if usually for academic studies, Gamri is the most used instrument.
Okay. Is
Okay.
it pirated or paid software it is, madam?
No, it is a paid software, but you can
Paid.
also I can give you a contact of Biologic. You can ask
Okay.
for 1 or 2 day trial, free trial,
Okay. Okay. No
if you
issue.
want.
Yes. Yes.
Yeah.
Okay, madam. Yeah. Yeah. Thank you.
Yes. If you want to know more about this, I can share some literature with you. The mechanism of this electrochemical method is very simple. You can see here, whatever metal you want to study, that let's say I want to study a weld material or a solder, that becomes my working electrode, which is anode. And now I will use a platinum electrode, which is a cathode. Using this platinum electrode, I will apply voltage and shift the electrode potential of this metal. And as I explained, the moment it shifts from its natural electrode potential, it corrodes. Now, how I will measure the corrosion rate? The more electrons are getting transferred, the more corrosion is happening. How many electrons are transferring? I can measure it using a reference electrode, which is a standard hydrogen electrode or calomel electrode. All these electron transfer can be calculated by that software, EC Lab. And then using that electrode potential, we can calculate corrosion density. Using this formula, we can calculate the corrosion rate. This is a 1 year course for corrosion subject.
Okay.
Yeah, usually this corrosion subject is offered by material science department in any college.
Madam,
Okay.
there is
Okay.
one question in the chat box from
Okay.
Professor Umesh Mohod. Can we replace synthetic corrosion inhibitors with natural resources?
Yes, definitely we can. Definitely we can replace. There are some example of corrosion inhibitors as well. The problem with the natural inhibitors is their potential keeps changing with the time. They cannot be, I mean, they cannot be standardized easily. That is the main challenge. Some of the examples of natural inhibitors is turmeric, curcumin, and then sorry, hello.
Hello? Okay,
Yeah,
madam.
yeah. So tannins, and then this cashew nut shell oil contains corrosion inhibitors. So many are there, but you see, no, the cashew nuts, if I'm producing in India, it gives different kind of oil. If it is produced in Australia, it gives, the consistency is missing. That is the challenge. But it is a very interesting area to explore.
I think Mr. Umesh got his answer.
Hello, madam. One more doubt I have, madam.
Yeah.
Madam, there is a one more slide that is causes of corrosions.
Yes.
There is a environmental corrosions, chemical, physical, and
Hmm.
material. Right, madam? Out
Yes.
of this, from if you come to the environmental, there
Hmm.
is a humidity, temperature, pollutions, and salt water.
Hmm.
Basically, I am from Karnataka, madam,
Hmm.
near to Goa area.
Hmm. Hmm.
Whenever I seen that one, there, because
Hmm.
most of the cars they will
Hmm.
sell after 1 year they will going to sell.
Correct.
Whether it is a temperature effect or salt water effect, which one is the most effective environmental?
Okay. Okay. So it is combination of both, but salt is the most dangerous if you compare
Okay,
both. Huh.
okay, madam. Yeah, yeah, yeah.
So when you have only hot weather, you can see the interior portion of India here. Okay, like Madhya Pradesh, it is very
Hmm.
hot. but the
Yes,
corrosion
madam.
is less. But the moment you go to Goa, the combination of temperature and salt is deadly.
Yes,
It becomes
yes, madam.
so. There is one interesting study done by Professor Khanna. He was my PhD guide. He was
Ah,
studying this car corrosion in the coastal areas. We did this experiment in Chennai. So
okay.
what is happening is, see, for business people, this area is only few, na, only some 3 to 4% of area is coming under high corrosion, and most of the area is coming under low corrosion. So what
Yes.
they do is they use the low zinc metals in the car, and the car corrodes. So coastal people keep complaining about corrosion, whereas the rest of the India, they are happy with that coating. Now these complaints get ignored by our automobile industries. This is a huge issue.
Okay, okay, madam. Okay. Yeah. Thank you so much, madam.
One more question, madam, in the chat box. Mrs. Firdos Sayed, you used a hydrophobic technique for corrosion control. How much
Mhm.
is the lifespan of that coating?
Okay. So lifespan is a very subjective question. For example, if you're talking about just the role of environment, temperature, sun, etc., the coating is quite durable. It is, it was passing 5 years warranty. But what happens is it gets subjected to mechanical abrasion. It is vulnerable because of the nanostructures. It is vulnerable to scratches. If some dust is there, the coating gets scratched, and that's how it gets deteriorated. So the coatings which are currently available in market are very expensive, and if you see hydrophobic coatings available on Amazon, they are not going to work. You can try it. Many hydrophobic coatings are available. Their life is very poor.
Okay, madam. I think Sayed madam got her answer. Anybody else? Yes, I have one question, madam, that you have discussed about the sacrificial anode method for the
Hmm.
prevention purpose.
Hmm.
So instead of using alone zinc, alone aluminum, or alone magnesium, you told
Hmm.
its combination,
Hmm.
that is ZAM. But whether that is to be converted into alloy, these three.
Yes, this is an alloy coating, zinc,
Oh,
aluminum, magnesium alloy.
okay, okay. So this is the alloy. We have to coat it.
Yeah, yes.
Yeah.
So
And
how it is coated is there will be a bath of electrolyte which contains all three metals, and iron is dipped into that bath, and then this alloy gets coated on it, which is called as dip coating. Dip coating is one of the most common galvanization process, and there are also electrolytic methods to achieve it.
okay, so whether currently for the ship hull or any major equipments, they are using this coating method.
Yeah, dip coating is the most common method.
Okay. And one more is there that you are told about also self-healing coating, so in which a polymer is to be used.
Yes.
So which polymer generally used, madam, there?
Usually, these capsules are filled with epoxy. If I am using an epoxy coating, my capsule will also be filled with epoxy.
Okay.
But the capsule itself is a pH activated capsule. So, or either pH activated, or if there is a mechanical scratch, the shell gets damaged and it gets leaked.
Okay, madam. Thank you. So any other questions? So madam has shared many case studies during her career in the R&D with different companies. So I hope participants, those who are interested in the field of corrosion, have got the benefit of this. So if still any questions are there, we will welcome.
Sir, there is one question from my side.
Yes, sir. Please.
Madam, basically, I'm from computer science field. I'm not, aware of the concepts in the mechanical field that much, but I have a general question about the gold. There is environmental effect on gold after a few years. Is there any method that we can prevent for domestic thing? I'm actually asking. Is there any method? From which we can prevent this environmental effect on gold?
Gold, what happens to gold? Gold usually doesn't corrode. Gold is the most stable material, which is also called as noble material.
Is there after a few years the content or the purity of the gold will remain same or it will decrease, like?
No, it remains same for centuries. It
Okay,
is
okay,
a noble metal.
okay, so there will not be any much environmental effect on gold.
No.
Okay, ma'am. Okay, thank you.
I think that's why the price are
Yeah.
day increasing. It's
Yes.
reaching 80,000 per 10 gram.
Yeah. We keep on passing gold from one generation to the other. We have our ancestral gold, everybody, especially people from Karnataka.
Yes, yes. Okay, anyone else? Okay, so I hope there are no any more questions. So it's time to uh, thank Madam for her valuable time and informative session regarding corrosion and recent technologies in the coating to prevent the corrosion. So thank you very much from the organizing side and from AICT ATAL also for accepting our invitation and giving such a wonderful lecture. So thank you very much, madam. And the participants are asking for the PPT. So I will share it. Madam has already uh, given me the PPT. So tomorrow or today itself, I will share it in the WhatsApp group of all the participants.
Hello, madam.
Yeah.
Yes.
Yes.
Madam, can you share me the related materials, that research materials? Because
Yeah, definitely.
basically I'm an electronics and communications field background, madam.
Mm-hmm.
So these materials will help me to
Mm.
study in electronics corrosions, that chips, some electronic chip will be
Semiconductor.
there. So
Yeah,
in that one it will help me. So because it is very
definitely.
important and interesting part. And one more thing I wanted to share you, madam, for all.
Mm.
I have observed one more materials which they are
Mm.
using for telephone line poles. That is
Mm-hmm.
also not getting corroded.
Mm.
It will be gives very long life.
Mm.
So is it the same or is there any difference between the normal
Those
materials and
metal poles, right?
yeah, metal poles, metal poles. Basically,
That is,
that
yeah,
that poles is basically used for telephone lines only, not other things.
correct.
Yeah, madam.
So that is made of galvanized steel.
Yes, right, madam.
Usually galvanized steel, there are many varieties. Uh, like I told you, zinc, aluminum, then zinc,
Madam.
aluminum, magnesium. There are many varieties. And also the thickness of zinc coating. The more zinc you put, the more electrons and the more stability of the structure. It is made of these coatings only, which are expected to give 50 to 100 years life.
Yes, right, madam. Thank you so much, madam.
Okay, I wanted to give an idea how material science and corrosion can be, very interesting subjects in industries. In India, we lack bright students in these fields. I encourage you to consider this as one of the option in your masters and PhD.
Yes, madam. Because I am planning to do the PhD, so it will help me. So can you share me the details, contact number or email ID, which it can help
Definitely,
me?
I will share. I will speak to Professor Avinash, and we will find a way to connect.
Yes, thank you so much, ma'am.
I will share my LinkedIn profile with him.
Yes, madam. Yes. Okay. Anyone more? Okay. So I will take the opportunity here to thank madam from on the behalf of all the participants. Uh, Madam has given excellent presentation here, and in spite of her busy schedule, she has accepted our invitation and also delivered the session here. And the industrial experience are really helpful for all of us. So thank you very much, madam. And tomorrow I will share the PPT. Is there any problem, madam? Can I share the PPT?
Yeah, sure, no problem.
Okay, madam. Okay. So thank you very much, madam, once again.
Yeah.
And we'll be in touch. If anyone is interested, I will share your what you share the materials and all that.
Yeah.
So thank you, madam. Thank you.
Thank you so much for this opportunity, and it is my pleasure to see all these young people, and I am looking forward to interact with them. I will share the materials as well. Thank you so much.
Okay, madam. Thank you and good night. All the participants, the feedback come attendance link is shared in the chat box. So all of you take cognizance of that and fill your feedback. Okay, so feedback